If you haven't watched l6v1, I will highly suggest you watch this because it deals with the open loop and the closed loop system. And if you still remember from the previous videos or your previous lesson, we actually say that this thing is the open loop system. If you have like a plus b, a minus bk xt, then it's a closed loop system. Alright, where is equals to x dot t. We have proved to you that. Alright, you can watch the series of the video, alright, on not question, but rather than lesson 5, 1, 2, 3, 4. You can watch all of them. Alright, so in this video, or in this series, we will mainly focus on the open loop system, which is this thing. Okay, because I don't know why, but let's see how it goes. Okay, in the past we have somewhat proved to you that you can transform this one into a Laplace domain. Alright, and we say that this portion over here is your g of s. Correct? Now, alright, we somewhat want to change your x dot t or your xt, alright, that is into the controller to something else. Okay, we want to change your xt that is going to input into your controller to something else, but it's similar because sometimes your controller may not be the same. You may have different controllers. You may have PID controllers. You may have other types of controllers. So it may take in different language, so to speak, or we can say that it's different variables. Alright, different variables. So you want to transform our x, alright, such that it still have the information within this thing. Alright, so I repeat again, we want to transform x such that everything stays the same, the information within here stays the same, but alright, we are using different values of x. Alright, so if you change different value of x, you will change different value of a, different c, different b, and different b. Okay, so verbally I can't prove to you anything, so that's why I need to prove to you now in this video. But the purpose of it is to prove to you in this video the transformation system. And we're going to use what we call the similarity transformation. Okay, so how do we do this? Alright, I'll just paste this thing, copy, and just go all the way here and paste this thing over here. Okay, so this transformation is a linear transformation of xt to x bar t. Alright, so you're somehow going to transformation inverse. Alright, so you're going to inverse transform your xt to x bar t, or on the other hand, you can transform your x bar t back to your st. Okay, so it's just the definitions of it. So we want to transform our xt. So this is some of the information that you want to define. Alright, so if that's the case that happen, alright, we can transform this whole thing into something else. Okay, so x dot t over here, alright, x dot t over here, you can say that is x dot t, alright, is something like this. Sorry, tx bar dot t. Okay, so we can somewhat say that our x dot t now, alright, can be rewritten as t x bar dot t. Right, we have proved to you that. Okay, so likewise, xt over here is tx bar t. So I can rewrite our xt as tx bar t. Alright, plus ut doesn't change at all because we are only concerned about the xt that is going to input into the controller. So therefore the ut simply is the same. So just simply leave it there like this. Okay, and this is it for the first one. Now the second one, output, we aren't somewhat interested in the output also. We didn't actually define anything for the output. So cxt now we can actually change this xt also. So we change it to tx bar t, alright, plus dut. Okay, so dut I didn't change at all, I just put it all over here. So far, what I've done is to transform xt, and x dot t. That's all. I only changed this stuff. As you can see, I change it to x dot t, I change it to this one, xt I change it to this one, ct, this one I change it to this one. Just take a look and compare. Alright, I'll give you another 5 seconds more. Okay, are they the same? Yes, they are the same. But however, we haven't finished yet. Alright, although we changed xt, to tx bar t, we haven't defined x dot bar t yet. So we're going to transform it again. Alright, since we know that if we want x bar t, alright, we can actually inverse transform this. Okay, and please take note, alright, this is a very powerful misconception, is that this t over here and this t over is a transformation. Alright, take note, this is not transpose. It's not transpose. Be careful of that. Alright, so this transformation t is a transformation. Okay, so what we're gonna do is to re-represent our system as x dot bar t over here. So I have t minus 1, and t minus 1 over here. Okay, because I want to change everything. Alright, I want it to be x dot bar t over here. Alright, because as you can see, this is the open loop system. Now it's x dot, I want it to be x dot bar t over here. I want this to be also like this. Sorry, I want this to be like this. Okay, we want to transform it. So what we can do is to use this transformation. Okay, and therefore this transformation, alright, for x dot bar t, alright, this inverse transformation times this transformation itself is just giving back 1. Alright, you can take it as, for example, although t is a matrix, we know that we should also inform you, alright, that t is a non-singular system. Alright, it's a non-singular. Alright, so they are independently like for example 1, 2, 3, 4. Alright, they are independently in terms of rows, they are not the same. Alright, if they are totally not the same. In terms of column, they are also not the same. So therefore they are non-singular. That's the meaning of that. They're independent of each other, all the variables. But I just want to prove to you in terms of numbers, so that is like something that's 1. Why is this 1? Because I think you may forget or whatever. But anyway, t is, for example, if t is 2, alright, inverse of t, because if t is 2, inverse of t is just half. So half times 2 is equals to 1. So at least you get to see the meaning behind that in terms of one number. If it's not a matrix, it's some dot, the same meaning. Okay, so therefore what I have is x dot bar t over here is equals to, alright, t inverse at, alright, we can simply rewrite it as a bar, and then I can keep this as x bar t, then plus t inverse b, I can say that it is b bar, I can keep it as ut over here. Okay, likewise for ct, I'll just say that this is c bar, x bar t, plus d, I can just say that it's some d bar. Okay, I don't know why you want to transform, but you didn't implement any transformation also, but never mind, let's just leave it there first. Some notation telling that it belongs to a system of transformation stuff, while the yt is the same because we didn't transform anything. Okay, so the key step I just want to convey to you is that at first we transform xt, and x dot t. Next we only inverse transform the first row. Alright, we only inverse transform this one, alright, to get this one over here. That's all. Alright, we didn't do anything about the second row. Alright, so be very careful of this thing. Okay, also be mindful of how to derive these things. And therefore all your so you can so this is the transformation for your these things over here. Alright, so to some extent you have somewhat transformed, alright, maybe hold on a while. You have transformed this thing into this thing, while they're exactly the same. Why? It's because first you transform this one time, it becomes x dot bar t, and then you transform again, you get back the same thing, because you're just transforming 2 times, that's all. I think you get what I mean. So this thing over here is exactly the same as this thing. They didn't change at all, but it's in the different domain. This is in terms of x dot t, this is in terms of the x dot bar t. Okay, and the values are changed already. The a over here is just simply a. Over here the a is t inverse at, while over here the b is b. This one becomes t inverse b. Alright, c and the d are correspondingly changed. Alright, so you can just take a look. Alright, so there are a few things that change, A to some extent didn't change at all, the symbol changes only. B definitely changed because you're going to transform inverse. C also definitely changed, while D stays the same, just the symbol changes only. Hope that this is pretty clear for you. Symbol change means that instead of A, I write as A bar, but you know that intuitionally transform inverse of AT is going to get back A, I guess. Alright, so to some extent, we just leave it as a symbol will do. Alright, same thing, D bar is D. You see the symbols aren't the same, because this is D bar. The symbol aren't the same, but the meaning are the same, the matrices are the same. Alright, so be kind of careful of that. Okay, and nonetheless, I don't think that this thing over here is A. Okay, I think there may be some other matrices. Just take it that this is the key thing that you need to memorize: A, B, C, and D. Alright, you need to memorize this so that you can successfully transform these things into these things over here. Alright, and how do we use this? Alright, how do we use this? From here, you can see that X is clearly going to input into the controller. Alright, and we say that different controllers, alright, will have different input variables. So you need to be prepared, and therefore in such a case, you'll transform it into X bar. So X bar T is your whatever transformation that is. Alright, so your transformation can be any values. Alright, your T. So T transformation is a very powerful understanding, because T can be anything. It can be 3, 4, 5, 6. As long as columns and rows that are not the same, they are considered a good T to transform. So you can almost have a lot of transformations possibility that can transform this thing into this thing with a different values. Or you have many possibility to do that. Alright, so this is the key thing that I just want to convey. Alright, however, if you to send this thing into the controller, normally you will want to represent in terms of a transfer function, right? And if you to remember, we actually change this thing to the Laplace domain, and we actually state that this is the transfer function g of s. Okay, likewise for our transform case, alright, what we can actually do, alright, I'll just write that down to in front of you. Alright, we can straightaway transform this two stuff into what we want. Alright, X bar dot T, A bar X bar, C bar X bar, and then B bar D bar. Okay, so you have transformed this thing straight away already using the definitions that I've shown you just now over here. So we have somewhat proved to you, alright, using all this definition. You just sub it in only. Okay, you can compare the value, so I'll just simply copy this thing and paste it here. Alright, it's the same. Alright, we didn't cheat your feeling. So I just want to prove to you that you can easily transform your stuff all the way. You can just take a while, just one or two seconds to just check it out, compare. This thing over here is the same as this thing. I've just transformed it. This thing over here is the same as this thing. I've just transformed it also. Alright? And therefore, at least you get to see how we transform stuffs from one to another. So therefore, we can just simply transform this also. Alright, C bar, A bar, B bar, D bar. Alright, do we have any X? There's no X's, so we can just leave it. So as you can see, your transfer function over here is in terms of a bar already. Alright, and then you can just simply sub it into your controller. Alright, and that's all. Okay, because this thing over here, the transfer function, is already mixed with a controller, and we are actually kind of keen to look at these things more than this thing, because this thing is simply a transformation of X, alright, which is the transformation of this one only. Alright, we are keen to look at the transfer function of the controller, and the transfer function of the controller is simply your YS, alright, which is based on this thing over here. So all in all, the first step you need to do is to transform all this, alright, and also transform your transfer function. So once you know your transfer function, because C, as you know, is your controller, your A and your B and your D are all these things, A and the B, and D over here is a feedback system. Do you see any feedback system? No. Alright, so D is something slightly different, but anyway, you just keep it first. So therefore, you somewhat get a feel of it already. Yeah, we are somewhat transforming one form of information to another form, but they're exactly the same. So now this is an X bar now, okay, where we have A bar, b bar, x bar, and dot. Okay, so this is the full transformation from one place to another, and they are exactly the same, but different values, you can say that different language, so to speak. Alright, so they have really different values, because your t itself, as I say earlier, you can have 1, 2, 3, 4, you can have 5, 6, 7, 8, you can anything, as long as the columns or as long as the rows or the columns are not the same. As you can see, the rows over here, they can't be re-represented by, let's say this one cannot be represented by this one, right? So therefore they are independently different, right? And therefore we can call this a non-singular. So your t itself must be of this quantity so that you can transform your system. So be mindful of this thing, okay? And therefore I think we are ready to go on to other stuff. See you there.